Okay, so this is the part 2 under fluid statics. This topic is about hydraulic machines. A hydraulic machine uses components such as pistons, pumps, and hoses to transmit forces and energy using fluids. Okay, so take note, ang fluids na involved dito is incompressible. Kasi hindi ka makakapag-transmit ng force kung compressible yung fluid na involved. So, pwedeng uh, motor oil. So, pwede yun. Incompressible yun. Wag lang, for example, air. So, air is compressible. So, hindi mo siya pwedeng gamitin dito sa hydraulic machines. Okay, so hydraulic machines are applied in braking systems, forklift trucks, power steering systems, airplane control systems. So kaya siya dito ina-apply kasi itong mga systems na to, this requires a large amount of force as output. So your input is a little amount of force pero yung output mo is a large amount of force. So braking system, forklift truck, magbubuhat ka ng mabigat while exerting less effort. Okay, so hydraulic machines uses the Pascal's law. It states that pressure applied to an enclosed, so walang leak, enclosed, and continuous body of fluid is transmitted undiminished. So walang nababawas na pressure or force to every portion of that fluid and to the walls of the containing vessel. So, ito, to give you an idea, a hydraulic jack is an example of hydraulic machine. So, meron ka dito lever. So, yung unang piston is maliit. Then, yung second piston is larger diameter. Para mas mabigat yung malilift mo. So, F2. Okay, so sample natin. Hydraulic jack has the dimension shown. So, we have 1.5 centimeter diameter piston number 1, and piston number 2 is 5 centimeter diameter. If one exerts a force F of 100 Newton on the handle of the jack, so 100 Newton daw itong F na to, what load F2 can the jack support? Neglect lifter weight. So pwede kasi na itong lifter is mabigat din. So mag-a-add siya sa weight nung load. So in this problem, we assume that lifter weight is negligible. Okay, so there's a force F, 100 Newton, applied to the handle of jack dito sa dulo. Now we are tasked to find load F2 in kilonewton that the jack can lift. And we assume lifter component is negligible. Okay, so what principle can we use? First, we can calculate the force F1 acting on the small piston. So dito mayroon siyang force by applying moment equilibrium. So mamaya isolve natin. Next is to calculate pressure P1 in the hydraulic fluid by applying force equilibrium. So makakalculate natin yung pressure dito sa small cylinder, which is of course equal sa pressure dito sa large cylinder. Now, calculate the load F2 by applying force equilibrium. Okay, so yung una, moment equilibrium dito sa lever arm. Yung pangalawa and pangatlo ay force equilibrium na. So magbabalance lang yung forces dito. And also yung moment dito is 0 din. So now let's compute. Okay, so let's choose hinge or C as our moment arm. So yung moment sa C, since stationary yan, hindi gumagalaw, is 0. So let's denote counterclockwise direction as positive. So substitute na natin. We have here force F multiplied by the distance from the moment arm, which is 30 cm plus 3 cm or 0.33 meter. Now, yung force F1 natin is pataas. So, clockwise siya. Kaya siya negative. And yung distance niya from C is 0.03 meter. And so, equate natin yung 0. Malalaman natin na ang F1 ay 1,100 Newton. Next is force equilibrium sa small piston. So, makikita nyo dito, pressure 1 times area 1 is equal to F1 dahil ang movement ng piston along Y is 0. So, forces upward is positive. So, we have F1 minus P1A1 is equal to 0. Now, F1 is equal to P1 times this area. So, yung area is pi d squared over 4. Equal siya sa 1100 Newton, which is F1. So, yung diameter natin is 0.015 meter. Okay, so, masolve na natin yung pressure 1. We have 6.22 times 10 raised to 6 Newton per square meter. Now, since yung pressure dito along the fluid is equal, so P1 is equal to P2. So, ang movement nitong large cylinder is, yan. This is at rest, so summation of forces along the Y is 0. Upward forces, positive. So, we have P1 times the area, A2. So, A2 na yung ginamit natin na area dito, less F2. So, F2 yung weight ng load, equal to 0. Okay, so substitute. Pressure 1 is 6.22 times 10 raised to 6. And the area 2 with diameter 0.05 meter. Finally, we have F2 is equal to 12.2 kilo Newton.